Hey everyone. All right. Well, you know what time it is. I'm going to just make sure everything works. All right. I'm just waiting to see that my stream is up and running and that I can hear myself properly. Okay. Let me just finish. That's not bad. And let me just see here. Okay, that's good. Okay. I think I'm all right here now. Let me just switch to the usual system. Okay. Just mute myself. Okay, there. Okay, great. So, just a couple of quick things. Last time I had the problem. This is from a different book I was doing. Anyway, you can catch all my streams on my channel, of course. When I was finishing off 1.5, my microphone cut out for some reason. I don't know why. I mean, I still answered it. You can tell on the screen, but I'm just gonna do it right here, right now, and get that one more time. So we're just going to do the last of 1.5, and then we're going to go into 1.6. So we have R by Z. So the reals by integers, and the intersection between integers and reals, okay, equal to by, okay. Okay, so that's the question. So if we take this, the way we can do it, we could try to graph it, but there's another way. So I just come up with a quick and dirty real set. Let's just say R would equal something that's in reals. Let's say I kept using this one 3.6, comma. Actually, let's make this negative, and then we're going to say this 3.7. Okay, and then we're going to say that our integer set is going to contain -3 and +3. Okay, so we're gonna cross multiply those and see what type of set that we're gonna produce. Um, if this is true, this would necessitate it would have to be an integer by an integer. So essentially, the ordered pairs produced would have to have of the type as my bottom z down here. So let's do it. Let's do cross multiplication. So we're gonna say z by r is equal to, all right, and we're creating set. Let's create a set here. Okay, so, all right, we have r1. Actually, this is z first, sorry. It's going to be z, -3 and -3.6. And then it's going to be -3 and 3.7. It's going to be 3 and -3.6 and 3, 3.7. Okay. So we don't have to prove what type this is. We simply have to answer the question, is this true or false, that it would create an integer by integer set? And the answer is false. False. Okay. I hope that's clear enough. Basically, false. A z by r cross multiplication ordered pair set will produce ordered pairs of the type z comma r. So what happens is you could have, of course, with reals, integers are part of the real set. It's nested within it. The integers are nested within the real set. But since we are doing the full range of it, in this case, the reals range from negative infinity to positive infinity. And so you have everything except for like complex numbers or imaginary numbers. Everything else is in the reals. So while you will have eventually, you will have occasionally, I should say occasionally, a z by z type ordered pair, integer by integer. You will, you can, there's no way to stop that from happening with producing an r with a z type r. Where in other words, you will occasionally come up with, by occasionally I mean most of the time, most numbers are not whole numbers, and for real, there's more numbers between 0 and 1 in the real set than there is all the integers, because you could subdivide the space between each space, and that increases at a much faster rate than just going linearly. Because look, let's say here, so we're gonna say and contains, let's just say 0 and 1, right? Okay, so just this range between this, right? We can go here, we're going to say this is 0.5. And over here, we can say this is 0.25. And then over here, we're going to say 0.125. And then over here, the same thing is another space between the two spaces, which is now half. So the point is you can keep subdividing it. And the problem is each one continues to subdivide. So at a much faster rate than saying strictly going one at a time, here, 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 here into the negatives, minus say 5, and 1, 2, 3, 4, 5, working your way toward the positives. So the real is infinitely bigger than the integers set. Okay, that makes some sense. So the next thing we have is to answer. What about the statement? Now this was the intersection. Oh, hold on. Okay. Okay. I answered the question, and I know from yesterday that I answered it correctly, but it's incomplete because this is a intersection. So, we did the second part of the intersection. Wow, I'm sorry, I'm not awake today. Long day working today. Work till after dark using my light system. Okay. Yeah. So we're gonna say that now this time we're gonna take the same set. And then we are gonna again multiply. So r, this case, is gonna be, let's see, so reals is negative 3.6 times negative 3. So the order gets flipped. Negative 3.6 comma 3 comma 3.7 and negative 3. 0.7 comma 3. Okay, so that's r by z, and the intersection here, we just have to find whichever ones appear in both sets. Well, the way I did it, it's kind of a bad example, but we can fudge it and fix it. Let's see how I can fix this. If I wanted to have a set which, because these two sets, the way I did it, they don't intersect. The numbers are just too different. Maybe it's a bad example. I should let me do another example here. Let's see. We want to have 3 and negative 3. Okay. Hold on a minute. Hang on a minute. Hang on. C by R. So, -3 if my r's are here. Okay, so if I wanted to recreate the second set, where it's r by z, z by r, I can't recreate that because that's a fraction. Let me try another set. Let me see if I go with, wait a minute here. Wait a minute. Okay, well, let me see here. I'm gonna take some of this stuff off. The union. Well, let me try. What if I did the union of this instead of the intersection? So anything goes. We add them all up together. If it's the union, would that produce an R by R set? Actually, I think I got the order of truth and false backwards here. So I think. Okay, I'm gonna fix this here. Okay. Let's try this again. Okay. The two sets that I created, one is R, the other one's Z. Z by R and R by Z. They will not intersect. So the first part must be true. The only kind of intersections they can have is when both are integers. Because yeah. Let's say this is true. Hmm. I learn new features all the time. Okay. All right, let's do this. So I'm going to argue that the only way that you can have there we go. Okay. New way the so this is what I'm going to say. I say that's true. Again, I may be misremembering something from last time, but this should be true. Yes. Well, this is good. Now you see what happened where I misremembered something, and I was dead certain that the answer was false, and I was just kind of rolling with it. But then when I looked at the numbers, see, math doesn't lie, right? It makes you really, if you pay attention, you'll get the truth. Look at the z by r and r by z. There's no intersection. I intentionally made the r's, the reals, exclusive to the real set, and the integers are in integers, of course. They are represented in the real set, but I wasn't gonna make the reals integers because I could have, but that wouldn't tell me anything. You want to find where the perimeter of your knowledge is, so to speak. You want to reach the limit, and that's how you get the information. Because this way, I can test the hypothesis. And yeah, my hypothesis was wrong, so I answered it true, and then that turned out to be the correct answer, which is great. What about good. Now, mm, union. Okay, so we have r by z and z by r, and this is the union. So, um, this is false for the obvious reason. So, hold on, maybe not. Just think about this for a minute. So, if it's an r by r set, that means the whole grid is represented. We just have to think of some number that would not appear in the grid, and any number really that's an integer because it's more restrictive. They're whole numbers on the positive and negative axis. So let's see here. If we just combine the two sets we have here, what do we get? Well, we get negative 3 and 3, but also hmm. Hmm. So for example, let's say here, let's say 3. 6, this is 3. Okay. So we have a point here, right? Now what if we wanted negative 3.6? Okay, so we have in the x-axis, when that's going to be, or positive, let's say here, we'll use 3.7. Fine, whatever. Okay, this is going to be 3.7. But over here, I can't. Okay. In order for every dot to fill in, we can't have false. The set. Okay, actually pretty straightforward. An order pair made up of a real will not be represented due to the whole number limit of z. So integers. So in other words, like you, let's see. So let's see. We're gonna say 3.6 comma 3.6. It can't. There's no way to get there. We can do like say 3 comma 3.6, or we can say 3.6 comma 3, but we cannot get 3.6 3.6. Okay, so and that's, it's one of those points. Each of these points, they're like numbers in the sense that there's only one of each, right? You can't have another number 2. There's only one number 2 that exists, and only one number 3. So in this case, this coordinate 3.6 comma 3.6, you can think of it as a number, and it is distinct and unique and special in the sense that you could only get to it by applying these coordinates. And because both are reals, there's no way to do it. So yeah, that's false. All right. Okay. Perfect. Okay, good. Yes, the book agrees. All right. 1.5 is done. All right. Now, let me see here. I'm going to stop the stream because I spent 24 minutes on it just to answer this last question. And then I'm going to go to 1.6. Okay? Let's do that.